All right, we're going to pick up where we left off working with exponents. Last time we did the multiplication properties. This time we're going to start with the division properties. So let's start with negative exponents. If you have a negative exponent, you will need to move that item to the other side of a fraction. And make the exponent positive. Now, in order for something to be considered simplified, so if you're asked to simplify something, all of your exponents have to be positive. So here's what that really looks like. If I have x to the negative 2, I'm going to make a fraction bar. X squared is going to go on the other side. Currently it's on the top, I'm going to put it on the bottom. And I'll fill in a 1 on top. And that's it. If I look at this another example, 1 over x to the negative third. I'm going to draw my fraction bar. X to the negative third means I need to put x to the third on the top instead of the bottom. I can leave that over 1, which really is just x to the third. What about the next one, though, where only one of them has an exponent? Well, I can draw my bar. X squared is the same, so I'm going to put x squared on the top. Y to the negative 2 means that I need to put y squared on the bottom. What about this last one? It's already a fraction and they both have negative signs. Well, I move them to their opposite sides. Z to the negative third is on top. So that means z to the third is going to be on bottom. Y to the negative 20th is on bottom. So y to the positive 20th will go on top. The next is the division of powers. So what if I had two things that were the same, but with different powers, and I'm dividing? If they have the same base, or the same big component, subtract the exponents. So if I had a to the n divided by a to the m, I really have a to the power of n minus m. I'm going to subtract them, top minus bottom. So x to the third divided by x to the second is really x to the 3 minus 2. And 3 minus 2 leaves me with just x to the 1, which is the same thing as x. If I have x to the 5th divided by x to the 7th, that means I have x to the 5 minus 7, which is x to the negative 2. But remember, we just learned we're not done if we have a negative exponent. So negatives bring it to the other side of a fraction. I draw my fraction bar. This is currently on top, so I'm going to put it on bottom. And I'll throw a 1 up top because I need something up there. That would be my final answer. Another option is you can think 7 minus 5 is 2, and 7 was on the bottom, so my x to the second needs to stay on the bottom. Remember, though, we said they had to have the same base. They needed to be the same thing raised to a power. So in the next example, x to the 5th, y to the 3rd, over x to the 2nd. The only thing that I can combine are my two x's. Remember, you have to combine like terms. So this becomes x to the 5 minus 2, and I just bring along my y to the third. 5 minus 2 is x to the third, y to the third. Now this last one starts to look really tricky. Remember, I can only combine things that are the same. So I can combine this x on top with the x on bottom, and that gives me x to the negative 2, and this x down here has a 1, so minus 1. And then I can combine my two y's. So I have a y to the third on top, minus my negative 2 from the bottom. So then I can simplify. Negative 2 minus 3 gives me x to the negative 3. And 3 minus negative 2, minus a negative, change. That gives me y to the 5th. But am I done yet? Of course not, because I still have that pesky little negative exponent. So I draw my fraction bar. If it's not actually in a fraction, we always assume it's on top. So x to the negative third is on top. I need to move him to the bottom to make him positive. And then y to the 5th is positive, so he can stay on top. And those ones are done. We have two more rules. The first one is the zero power property. This one's pretty simple. Anything to the 0 power is 1. It doesn't matter what it is, if you raise it to a power of 0, your answer is going to be 1. So 3 to the 0 power is 1. 257 to the 0 power, still an answer of 1. X to the 0 power, really just 1. And even if I take a big old mess of things and raise it to the 0 power, so x to the third times y to the 5th times z to the 7th, all of that to the 0 power, still an answer of 1. Doesn't matter what it is. Your answer is always 1 if you're raising to a 0 power. And last but not least for this section of notes is called powers of quotients. So what that means is if I have a fraction raised to a power, I distribute the power to every piece inside. So fraction raised to a power distribute power to all pieces, top and bottom. So if I have x divided by y, and that whole thing's raised to the third power, I'm going to raise both the x and the y to the third power. My answer ends up being x to the third, y to the third. What if I had more than just that? What if I had x to the third, y, z? I'm going to distribute my square to each one. And I end up with x to the third squared, y squared, all over a z squared. But don't forget our rule from last time. A power raised to a power, I need to multiply. So 3 times 2, that gives me x to the 6th, y squared, all over z squared. And that is my final answer. So we might have to use our rules from earlier to solve some of these too. What if I look at this next one? I'm just going to distribute my square to the top and bottom. 2 squared over x to the third squared. And then simplify some more if we need to. 2 squared. 2 times 2 is really 4. And remember, a power to a power, I multiply. X to the third times 2. So x to the 6th. That is my final answer. And one more just for good measure. Let's do it in this nice purpley color. I distribute my -2 to each piece. So I have x to the third raised to the -2 over y squared raised to the -2, z to the -2 raised to the -2. Power to a power means I need to multiply, so I multiply all of my powers together. 3 times -2 gives me x to -6. 2 times -2 gives me y to a -4. And 2 times a -2 gives me z. Negative times a negative is a +4. But I'm not done. I still have negative exponents. So I draw my fraction bar. And I'm going to start at top. X to the -6. Well, it's on top, it's negative, so it needs to be on bottom to be positive. Y to the -4 is on bottom. It's on bottom, it's negative, so to be positive, it needs to be on the top. And then z to a +4 means he does not move. This makes my final answer. And that's it for this section of notes. Remember, negative exponents, flip it to the other side of a fraction. And if you are dividing things that are the same, you subtract their exponents. Anything to the 0 power is 0. And last but not least, if you have a fraction raised to a power, distribute the power to each piece inside. That's it for this unit. You've got a quizzes assignment. Try your best and have a great day.